Okay. So on problem number 1, well, on both of these problems, we're supposed to use the linear combination method or the elimination method to solve these. That means either my x's or my y's need to cancel out when I add these two equations together. Right now, if I add these two equations together, will 3x and x cancel each other out? Give me a yes or a no in the chat, or you can just do y or n. Thank you, Alex. Yeah, if I add those two together, what will I get? 3x plus x. What would 3x plus x give me? Remember, if you don't see a coefficient in front of a variable, it's an invisible 1 there. So what would I get if I added 3x and 1x together? Absolutely correct, Genesis. I would get 4x. Okay, so those don't cancel. So let's come over here and look at the y's. If I add those two together, will they cancel out? Give me a yes or a no, y or n in the chat. Negative y and 2y. If I add those two together, will they cancel? What do you guys think? Y or n? Yes or no? Let's look at it. I have a negative 1y and a positive 2y. What is negative 1 plus 2? It's 1. Absolutely correct. When things cancel out, what I'm looking for is that they will equal 0. So these two together aren't going to cancel because I get a 1y and I want to get no y's. I want 0 y's left. So I love that we had the chance to have that conversation, because what I'm looking for to happen, is that I want the numbers, the coefficients in front of my variables to be the same number, but one of them is a positive and one of them is a negative, because that's how I will make them cancel out. So we already decided that that wasn't going to happen with the x's, and we just discovered that that's not going to happen with the y's, because here I have a negative 1y but a positive 2y. So what I can do to force them to cancel out is I could multiply everything in this top equation by 2. If I multiply everything in the top equation by 2, what would I get when I distribute 2 to every single piece? Tell me in the chat. What am I going to have if I distributed 2 to every single piece there? Two times 3x, 2 times negative 1y, and 2 times 3. Awesome. Thank you, Alex. We're going to get 6x minus 2y equals 6. By the way, this isn't the only thing we could have done. I just picked out something that we could do because I saw the 2 and the negative 1, and I saw we already had a positive and a negative there. And so I said, what can I multiply that top equation by to get the same number in front of the y, but a different sign? I'm going to recopy this bottom equation, x plus 2y equals negative 20. And I'm going to try adding these two together now. What's going to happen with my x's. Remember, that's a 1x on the bottom. What is 6x plus 1x? 7x, thank you. And then right here, -2 plus 2. I know it has the y's with it, but remember, when we're adding and subtracting things, we're only worried about those coefficients. What is -2 plus 2? 0. Right, so that means I have 0 y's equals, what happens back here? I have 6 minus 20. What is 6 minus 20? Six minus 20. -14. Now I want to talk for just a minute about this right here. What do I get if I do 0 times 5? What about 0 times 100? 0 times 1,000,000? What is 0 times y then? Yes. Remember, the coefficient is being multiplied to my variable right there. So this is exactly the same thing as saying 7x plus 0 equals -14. If I add nothing to something that I've got, it doesn't change it. 7 plus 0 is 7. 5 plus 0 is 5. 150 plus 0 is 150. 7x plus 0 is just 7x. So this is why it's called the elimination method. We have eliminated our y variable. We multiplied until we got opposite coefficients, same number, but one positive and one negative, so that when we add them together, they cancel out. They give me a 0. And so then I don't have any y's left. So from here, we're going to divide both sides by 7. And that means that the x part of my ordered pair would be how much? -2, yes. -14 divided by 7 will give me a -2. Not done yet. Because we still need to find our y variable. So I'm going to take that answer that we just got for x, and we're going to substitute it back into one of the two original equations that we had to work with. Good morning, Soraya. Give me a 1 or a 2 in the chat. If you want to use the top equation for us to substitute into, give me a 1 in the chat. If you want to use the bottom equation, give me a 2. It doesn't matter which one we choose. They'll both give us the same answer. Sounds good, Alex. Let's go with 2. So equation 2 says x plus 2y equals -20. And we are going to put -2 in the place of the x. So then from here, to get my y all by itself, I'm going to add 2 to both sides. What is -20 plus 2? -20 22, good thought. It's going to be negative 18. Here's what's going on. Here's why it's negative 18 and not negative 22. If I'm on my number line and I'm over here at negative 20, adding is going this way and subtracting is going this way. So if I'm going to add 2, that would be 2 hops this direction. That's going to get me closer to 0. That's why we're at negative 18. All right, so 2y equals negative 18. I'm going to divide both sides by 2. What is negative 18 divided by 2? Yes, don't forget the negative on it, but you're absolutely correct. Negative 9. Wonderful, wonderful. So my final solution here then, I need the whole ordered pair, because this is the point where these 2 lines intersect each other. Negative 2, negative 9. Awesome, let's go do number 2. Let's try to get through it pretty quickly because then I want to move on to what we're going to touch on in the lesson today. If I add these 2 equations together, will my x's cancel out? Give me a yes or no in the chat, y or n. If I add these 2 equations together, no. Negative 2 and negative 4 gives me negative 6, not 0. What about my y's? If I add these 2 together, will my y's cancel out? Nope, still a no. 7 plus 3 is 10. So I'm going to have to do some multiplying before I add these together. Last time we made our y's cancel out. Let's see if we can make our x's cancel out. Right now I have a negative 2x and a negative 4x. Is there anything that I could multiply negative 2 by so that I can get a positive 4? Super close, Soraya. There we go. Thank you, Alex. It's going to be a negative 2 because remember, I want one to be a positive and I want the other to be a negative. If I just multiply through by 2, I'm going to have a negative 4 and a negative 4, which is so close. But I want to get a negative 4 and a positive 4. Morning, Dexter. So I'm going to multiply everything in this top equation through by negative 2. So we're going to distribute that to every single piece. Tell me in the chat what we're going to get after I distribute negative 2 to every single part there. I'm going to have a 4x. Is the 14 going to be positive or negative, Soraya? Negative, so it's going to be minus 14y. And what about the 8? Will that be a positive or a negative? That will also be negative. Thank you, Alex. I saw yours as well. So 4x minus 14y equals negative 8. And then I'm going to recopy the bottom equation. And then we're going to add these 2 together. What happens to my x's? What happens with my x's? 4x minus 4x. It's going to cancel out. It's going to give me a 0x, which then just kind of disappears. Negative 14y plus 3y is going to be negative 11y. What about negative 8 minus 14? What's going to happen there? Negative 22. When I divide both sides by negative 11, negative divided by negative is going to give me a positive there. And that means y is what? Y is 2. Am I done? Is that my final answer and I can be finished and we can move on? Nope, not yet. We still need to go back in and figure out what our X value is. So give me either a 1 or a 2 in the chat to tell me which one you would like to use. First equation sounds good. All right, so I'm going to have negative 2x plus 7y equals 4. Negative 2x plus 7, and we're going to put 2 in the place of the y. What is 7 times 2? $14. Awesome. And then I'm going to subtract 14 from both sides. What's 4 minus 14? Negative 10. And then we divide both sides by negative 2. Negative divided by negative is going to give me a positive again. So X is 5. Nice work. Which means my solution is the ordered pair what? What is my solution for number 2? Absolutely, it's the ordered pair 5, 2. Nice work on the bell work today. All right, we are going to scoot into our lesson for today. We are going to talk about different types of solutions. There's 3 possibilities. There's 3 types of solutions. There's the possibility that I have one solution that's an ordered pair. That's like both of the problems on our bell work. We had an ordered pair. This is one answer. It's possible that I have no solutions. On a graph, this would be parallel lines. Lines that never touch. No matter how far out you take it, they're never, ever, 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 ever going to touch. If I'm working with equations, then I'm going to see X and Y both cancel. And then I'm left with a false statement. Something like 0 equals 5 or negative 7 equals 7. Those would be false statements. Those things are not equal. Infinitely many solutions. If I'm looking at that on a graph, the lines are on top of each other. With an equation, you're going to see X and Y both cancel out again. Let me write that down. They both cancel. There we go. But then you have a true statement. something like 0 equals 0, or negative 12 equals negative 12. Something that really is true. All right. I want to look at these graphs, and then we'll look at some equations, and we're going to try to determine how many solutions each one has. So on the first system, on number 1, I'm looking at the top equation. Where should I put my first point with the top equation on number 1? I'm going to do this line in purple, I think. Where should I put my first point? At 2 on the y-axis. Yep. And then what is my slope? Yes, 3 over 1. So we're going to go up 3 and right 1. So up 3 and right 1, up 3 and right 1. Make it go backwards as well. We want to run to the edge of the graph. Grab my straight edge and draw it in. Okay, so there's my first line. Where does my first point on the second line go? I'm going to do this one, I think, in light blue. Where's my first point go here? Negative 5. So this one has a y-intercept of 0, negative 5. And what is our slope? Three over 1 again. So we're going to go up 3 and we're going to go right 1. So from negative 5 up 3 and right 1, 3 and right 1. Going to do that until I run out of room and then turn it around and go backwards. And then grab my straight edge. Where are these two lines going to intersect each other? Never. So this is a no solution situation. Absolutely correct. One of the ways I know for sure that it's no solutions, they had the same slope, but they had different starting places. Same slope, but different starting places. Number 2, my y-intercept is going to be at 0, 4. And then where do I move from there? Where do I go from 0, 4? Down 3 and right 1. Yes. Slope is negative 3 over 1. So this is down. And this is right. Remember, if my denominator is positive, I'm going to go to the right. Right, do that to the edge of my graph. Switch it up, switch it around, do it backwards. Grab my straight edge. Go through those points. Next one, I'm going to do this one in green. No, I'll do it in light blue again. I see my y-intercept here. How are we going to move after that y-intercept of 0, negative 1? Where do we go from there? Yes. I see the negative out in front here. Remember, it doesn't matter whether you put your negative with the top or the bottom. It just has to go with one of them. If you put it with the top, then you're going to go down and to the right. If you put it with the bottom, then you would go up, but to the left. So down 2, right 1. Wait, down 1, right 2. What am I doing? Down 1, right 2. Down 1, right 2. Until I run out of room on my graph. Up 1, left 2. Until I run out of room in the other direction. Grab my straight edge. How many solutions do I have here? How many solutions do you see on the graph? One solution. There is one point of intersection. That one solution is the ordered pair 2, -2. It has an x part and it has a y part to it, but it makes 1 point, one ordered pair. All right, last one with the graphing. Y equals x minus 4. What's my slope on that top one? I know the -4 is my y-intercept, but what's my slope? Awesome, that's absolutely correct, Genesis. Soraya, yes. Alex, absolutely. It's 1/1. So -4. And then we're going to go up 1, right 1, up 1, right 1, until I can't go any further. Flip it around, go backwards. Grab my straight edge. All right, bottom equation. This is the only one that hasn't been in slope-intercept form. What do I need to do to that bottom equation before I can graph it? What do I need to do to the bottom equation before I can graph it? Absolutely. I need to get the y alone. To get the y alone, I'm going to divide everybody by 2. Remember, we have to distribute with our division the same way you distribute with multiplication. So I would have y equals what? (1x minus 4). What happened when I graph that? What's going to happen when I graph that one there? Absolutely, the lines are going to be exactly on top of each other. That's the exact same line as what I graphed before. So what does that mean about my solutions then? How many solutions do we have? Infinitely many solutions, yes. Infinitely many solutions. That means that they have an infinite number of points in common. They touch each other in an infinite number of points. They share all of them. All right. I want to look at this now with some equations. First set of equations right here. We get to decide what method we want to use. We already did the graphing method. So we're looking between substitution and linear combination. Linear combination is the one where you multiply and then cancel. Do you want to do the multiply and cancel on number 4? Or do you want to use the substitution method on number 4? Multiplication, cool. Do you want to make the x's cancel or do you want to make the y's cancel? Y's, okay. X's, sounds good. What do I need to multiply by if I want to make, let's see, Soraya, you picked the y's. What do I need to multiply by if I want to make the y's cancel? Genesis, what would I need to multiply by if I wanted to make the x's cancel? Remember, I want the same number, but the opposite sign. Soraya, what's 2 times 2? There we go. I want the opposite sign though. So if I just multiply everybody through by 3, well, I get the opposite sign. Because I'd want a positive 6 and a negative 6. Right now, if I distribute, I'm going to have 9x and 6y, but I already have a 6y. What would I need so that I get a negative 6y when I distribute? Negative 3, there we go. So I'm going to distribute a negative 3 to everybody. So I get negative 9x minus 6y equals negative 15. I'm going to recopy the bottom equation, 9x plus 6y equals 15. What happens when I add these two together? What is negative 9x plus 9x? They cancel. I get 0 x's here, but then I also get 0 y's. So that's the same as 0 plus 0. That's just a 0. What happens on the other side of the equal sign? Yeah, my 9s cancel out, my 6s cancel out. What happens with my 15s? They also cancel. So I get a 0 there. Is this true? Does 0 actually equal 0? Yes, 0 and 0 are the same value. So that means infinitely many solutions. I realize that infinitely many solutions is a lot to write out. You can abbreviate that like this, but you cannot write just IMS. IMS is not consistent mathematic notation. For all anybody else knows, you mean the Indianapolis Motor Speedway. So be careful with your notation. Make sure that you're using something that no matter where you go from Pike, they're going to understand what you mean. Let's look at number 5. Do you guys want to use the substitution method here or the linear combination method, the one where we multiply and cancel, or the one where we get a y or an x all by itself? Do I need to multiply to make something cancel? There's a thought. Do I need to multiply to make something cancel? No. On this one, if I add these two together right now, what's 4x plus 4x? (8x). What's negative 5y plus 5y? Zero. And then 12 plus 4 gives me 16. Oh, that should be an x at the front, not a y. Oops. 8x. So I would have 8x plus 0 equals 16. That's just the same thing as 8x equals 16. When I divide both sides by 8, that means x is what? 2. And then I need to take that and substitute it back in. I'm going to use the bottom equation this time just because I don't feel like we've chosen that one very much. 4 times 2 plus 5y equals 4. So I would have 8 plus 5y equals 4. Subtract 8 from both sides. 5y equals negative 4. And then I divide both sides by 5. I'm going to leave that as a fraction, but you could write it as the decimal negative 0.8. How many solutions does this one have? How many solutions does this have? Be careful. 1. Awesome. Thank you, Alex. This is 1 solution. It is the ordered pair 2 and negative 4/5. Remember, for 1 solution, you need an x part and a y part for your ordered pair. Let's do substitution on the next one, and then we'll be done. So on this top equation, I'm going to subtract y from both sides. And so I would have x equals negative y minus 7. I'm going to take all of this right here and put it in the place of this x. Negative 2, and then I'm going to substitute in negative y minus 7. Minus 2y equals 10. If you guys remember from last week, at this point I stop and look. Only y's left. If you still have x's and y's left at this point, you've made a mistake. And then we distribute. Negative times a negative gives me a positive. So I get positive 2y, positive 14, minus 2y equals 10. I'm going to combine my like terms together. What happens when I combine my y's together? Two y minus 2y, they cancel out. And I'm left with 14 equals 10. Is this true? No. 14 does not equal 10. So what does that mean about my solutions then? No solution. Nice work today, guys. We are going to stop there for today. Tomorrow morning, so you need to finish it up tonight. Tomorrow morning, 7 a.m., your third homework is due, the linear combination homework. Linear combination, again, is where you would multiply, if you need to make either the x's or the y's cancel out. You want to get 0 x's or 0 y's. So you want the numbers to be the same, but 1 positive and 1 negative. Your test is set for Tuesday, the 25th. We are going to work on some word problems, some story problems tomorrow. So please make sure that you come. Please make sure that you're here on time so that we can get going as quickly as possible. I know 7:15 is really early in the morning, especially when you don't have to get up before then and get yourself all ready. But thank you guys so much for coming today, and I appreciate your participation, and I hope you have a fantastic rest of your day. Bye, guys.